Dear students, welcome to my 7th class on Module 5, Sampling Theory. In this lecture video, we will be discussing students' t distribution and problems on students' t distribution. Test of significance for small samples. When sample size n, which is less than or equal to 30, we will be applying the concept of students' t distribution. And also we have to learn the concept of degree of freedom. So to calculate this degree of freedom, the formula we have is V is equal to n minus 1. So where n stands for sample size of the given population. To calculate this students' t distribution, the formula we have is modulus of t is equal to modulus of x bar minus mu by s into square root of n. So this x bar is nothing but sample mean, mu is nothing but population means, s is nothing but standard deviation of population, and n is nothing but sample size of the given population. So to calculate x bar, sample mean, the formula is x bar is equal to 1 by n summation I from 1 to n xi. And to calculate sample variance, so s square is equal to 1 by n minus 1 summation I from 1 to n xi minus x bar whole square. So with s square we can able to calculate s, and v is nothing but degree of freedom. It is given by v is equal to n minus 1 and mu stand for population mu. So in the problems we have to check the following three conditions. The first condition is if mod t is greater than t 0.05, the difference between x bar and mu is said to be significant at 5% level of significance. Similarly, if mod t is greater than t of 0.01, the difference between x bar and mu is said to be significant at 1% level of significance. Finally, if mod t is less than the table values, then we'll be saying the difference between x bar and mu is conformal. To calculate the confidence limit, we have to use the following formulas with respect to the population mean. The first formula is x bar plus or minus s by square root of n into t of 0.05. The one more formula is x bar plus or minus s by square root of n t of 0.00501. So this is called students' t distribution table. So this problem will be helpful to check the hypothesis while solving the t distribution problems. Example number 1. Find the students' t distribution for the following variable values in the sample of 8, minus 4, minus 2, minus 2, 0, 2, 2, 3, 3 by taking the mean of the universe to be equal to 0. So now take the formula of students' t distribution. It is given by t is equal to x bar minus mu by s into square root of n. So they have given that the value of mu is equal to 0 here. The sample size is n, 8, that is n is equal to 8. Now we have to calculate the value of sample mean and sample variance. So x bar will be equal to 1 by n summation I from 1 to n xi. So it will be equal to 1 by 8 minus 4 minus 2 minus 2 plus 0 plus 2 plus 2 plus 3 plus 3. So after simplifying this, we got the value 1 by 4. It is equal to 0.25. So we got the value of sample mean is 0.25. So next is sample variance. So the formula is s square is equal to 1 by n minus 1 summation I from 1 to n xi minus x bar whole square is equal to 1 by 7 into minus 4.25 whole square plus minus 2.25 whole square plus minus 2.25 whole square plus minus 0.25 whole square plus 1.75 whole square plus 1.75 whole square plus 2.75 whole square plus 2.75 whole square. So after simplifying this equation, we got s square is equal to 7.07 and s will be equal to 2.66. So now replace this x bar, mu, n and s value in the equation. So we got t is equal to 0.25 minus 0 by 2.66 into square root of 8. The value of t will be equal to 0.266. Example number 2. So here some sample of 12 patients has been given with the data like 5, 2, 8, minus 1, 3, 0, 6, minus 2, 1, 5, 0, 4. So now, so first take the formula. So in the formula actually what we're supposed to calculate, we have t is equal to mod of x bar minus mu divided by s into square root of n is the formula we're having. So according to the formula, we have to calculate the value of x bar first, s square, and the population mean also we have to calculate. So here the value of x bar is given by 1 by n summation I from 1 to n into xi. So replace all the data over here. So we got 1 by 12 into 5 plus 2 plus 8 minus 1 plus 3 plus 0 plus 6 minus 2 plus 1 plus 5 plus 0 plus 4. So after simplifying this, we got the value of x bar is equal to 2.5833. Similarly, I'll be calculating the value of s square. So s square is given by 1 by n minus 1 into summation I from 1 to n xi minus x bar whole square. So by replacing all the values over here, so we got the equation like 1 by 11, 1.04.9167. So it will be equal to 9.5379 is the sample variance. So S will be equal to 3.0883 will be the required solution we'll be getting. So now to calculate the value of t, we have x bar minus mu by s into square root of n, and here the population mean will be equal to 0. Therefore we got t is equal to 2.5833 minus 0 divided by 3.0883 into root 12. So after simplifying this, we got the value 2.8979, which is greater than of 2.201. So hence we can say that the hypothesis will be rejected at the 5% level of significance. Example number 3, the weight of 10 people of a locality are how to be 7, 67, 62, 68, 61, 68, 70, 64, 66, 66 kgs. So can we think that the average weight of a people of locality is greater than 64 kgs? Test the hypothesis at 5% level of significance with the value of t is equal to 2.26. So same like a previous problem only. So first we need to calculate the values of x bar. So x bar is given by 1 by n summation I from 1 to n. Xi is equal to 1 by 10, 70 plus 67 plus 62 plus 68 plus 61 plus 68 plus 70 plus 64 plus 64 plus 66. So after simplifying this, we got the value of x bar is equal to 2.5833. So now we'll be calculating sample variance. So sample variance is given by 1 by n minus 1 summation I from 1 to n. Xi minus x bar whole square, it will be equal to what? 1 by n, 1 by 9 4 square plus 1 square plus minus 4 square plus 2 square plus minus 5 square plus 2 square plus 4 square minus 2 square plus minus 2 square plus 0 square. So after simplifying this, we got the value of s square is equal to 10. So which is s is equal to 3.1623. So then the population mean is given by 64 here. So replace all this data in the formula. So we got t is equal to x bar minus mu by s into square root of n. So 66 minus 64 by 3.1624 into square root of 10. So we got 1.9999 as a solution. So therefore this t is equal to 1.9999 is less than of 2.26. Hence we can say that the hypothesis is accepted at 5% level of significance. Thank you.